diamond with a double bond. Draw the yellow in. And that's going to have a methyl up and one down. So do another diamond down here. Draw methyl up in there. You can finish that. Tell you what, whenever you get a methyl out there, draw the hydrogens on so it finishes it off. Then we can focus in more on the ring. Okay. So there's a 6-membered ring. So 1, 2, 3, 4. We got 2 more. We could do brother sister sideways here if we wanted. Let's see. We want to catch. We're going to have one coming off this way. So let's get that diamond out there. And to finish off the ring, it's going to have one coming down off this one. So let's go down and just connect it however you want. We'll use the line to be safe. So we're just going to draw a diamond in there and then we'll connect it. Connected on the side. Now this diamond here, it's got one that goes up. You get an OH off that, but draw the other one down. Big O. We'll finish that in a second. So now coming around here, 4, 5. We had 6 in that ring. Now we're going to have another 6 ring that's coming off this. This goes over, down. That can't be right. These two should be next to each other. How many do we got here? 1 up to a double bond with a methyl on it. To a 1, 2, to a 1, 2. Okay, this should come off there. No biggie. So I told you, this is how you do it. You got to double check yourself as you move along. It's not the line, it's this one. Be a believer. You can do it. All right. So just cover that up. Bring the diamonds, because we got to get this ring here in there, and I'm like, there's too big a space. Six. We'll just count backwards since numbers are 6, 5. 1, 2, 3. Only 4 is missing, and that's an O. So we can draw the O, watch this, right in the middle here to take care of both those inner ones. It's an ether, so we'll just color it in. And it looks like there's 2 methyls coming off this guy, so we're going to use the markers since we have draw some H's in here. Get a little confidence behind us here, okay? Inner ring, it's not aromatic. It's a methyl. It's a methyl. But finish these guys. We're coming around. There's only double bond is there, so that's going to make that a 1. It's got a side group, so that's going to get a 1. So you're going to have these 2s when we're used to the benzene rings with the double bonds. When we got these in here and they're just regular. Okay. So that's that ring. Now we got to come around here. couple numbers in there. 2, 3, make that a 1. It's a 6-membered ring. Oh, it's aromatic. I drew the shorthand now. I wasn't even ready for it. 3, 4, 5. Okay, so 2 more diamonds in here. We got double bonds and single bonds, so we better get this right here. Single, so this is going to get a double. Draw it in with the yellow. Remember, a benzene ring is always double, single, double, single. So single, double to a single. 6, 5, there's only one more in here. To a single to this one. So we want to go to there so that we can let the double hit this. Are we getting one off here? Double, single. That means this one's going to be double. Double. Nah, see, it still can't work that way. I messed it up there. Like I said, the worst you'll do is just make it where you gotta draw it across. So double bond. And double bond. So see, it looks sloppy, but you're learning how to make all the carbons have all their bonds. The correct number is more important than how you draw it. So that's going to be a Schroeder diamond, luckily, so we can color that all the way in. And we got some hydrogens doing these. If that's aromatic, these are all going to have 1s. And what happens here... Remember I told you the terpenes, 5 carbon long? Well, on carbon 5 here, there's a terpene. So 5, there's already numbers. Look how they work. 4, 3, 2, 1. Now, when you hear this tetrahydro, it's tetramethyl. There's one OH in there. That's this one. That's the alcohol. There's 2 oxygens. The other is this lactone. I call it an ether in the ring. Okay. There's 4 methyl side groups if you count that last one here, which I really don't. But that's the only tetra thing I can find. Okay, the delta-9. That must be carbon number 9 up there. That's the double bond. It's usually what you number with the deltas, I do believe. Omegas are the ones in your fatty acids. So something I noticed was one of these that has 3 on the side and a different, something else was missing up here. That's the one that has the non-psychoactive effect of making you paranoid and making your heart race and all that. So that's what they bred out, apparently, I guess. So color these in. Do the Schroeder diamonds first. Those are the ones with all the bonds to electronegative of a carbon or more. That one there gets it. And there's one. So see, this is fun. This has to be fun, isn't it? Looking for different carbons, getting to color them how they need to be. Number 3 here. So you start getting the feel for it. If it doesn't have a double bond and it's in the ring, it's not going to be the prominent Schroeder diamond. So see those? That's that. So now finish the hydrogens. These are just straight hydrocarbons. So 1, 2, 3,